Hey guys, how's everything going? This is JSer, who is not the good algorithms. In this video, I'm going to look at 2a6 walls and gates. We're given an mn 2D grid initialized with these three possible values. -1, a wall, or an obstacle. 0 means a gate. Infinity means an empty room. We use this value to represent infinity, as we assume that the distance to a gate is less than this. Okay. We're going to fill each empty room with the distance to its nearest gate. If it is impossible to reach a gate, it should be filled with an infinity. Well, the naive idea comes to my mind is that we just update the grid over and over again by starting with a gate, right? Suppose that this is the gate, and the 4 coordinates around it will be at distance 1. So we update them. So update to 1. And then we start with these 1 point. And then start, if it is obstacle, we cannot continue, right? So these 2, 1, and start searching for the next one. Inf here, so set to 2. Here is 0. Because it's smaller, we don't update them, or we need to mark them as already checked. Well, we see that -1 is mathematically it's smaller, so because it's smaller, we ignore them. So 4 or 3, 2 here. The next one, this is 1, so we get this, right? Infinity is bigger, so 3, 3, 4, 4, 4. This is the first round. We go to the next one, 0, and start updating. So 1, 2, 3, 4, 5, 6, 7, right? But here's the problem. I think that we don't need to go down to here, because you see the point here has a minimum 2 to 0 here, but when we are traversing through the nodes from this, starting from this 0, it's gonna be 3. So there is no need to step on this node with step 3, right? Because originally it's 2. So we stop here. So 1, 2, 3. Yeah. So the idea is simple. First, we loop through all points, and when we meet a 0, we start BFS, right? This is layer by layer. So breadth first search, layer by layer, update it, and in every update, we will push. Here we can use a stack. No, we use a queue. For BFS, we use a queue, but we're not use a shift, because in JavaScript shift is slow. We just use pop. Oh no, we cannot use pop. We use pop, we need to pop it again. Okay, we still need to use shift. Okay, so we push the node infinity in each node, in each layer, and push the coordinates into the queue, right? And do it over and over again. While we need to keep track of what's this current step we're getting, we could just store the coordinates together with the steps. Okay. Distance, yeah, together with the distance. Okay. Okay, so let's start. So for rooms, is rooms empty? We're not. If let's say rows, rooms, if it's empty, we return. Obstacles. Okay, now so we loop through all coordinates. If it is a gate, we will we will walk on it. Okay, the distance when we step on it is 0, so 0. So we define the walk method, which is I, j, and distance. So we use a queue. We put it into the queue. This is queue is array of it's x, y, distance. So while this queue is not empty, while this is not empty, we need to shift the elements out and push the next round of coordinates in, right? So as we did it before, we need to add an ending identifier. We push a null at the end, and we can start shifting elements out. Oh, we don't need to null because the distance is already in the queue. We don't need this. Sorry, my bad. The distance is in the queue, so we will just start with shifting the head. Every time we get a head out, what do? We can compare here or compare when we are pushing the element, pushing the coordinates in. Okay, we'll just compare here, right? So if, oh no. If it is the same, we won't do anything, right? We update it when we but for 0 we start with 0. If the distance is 0, we continue. But if it's not 0, it's not 0, it's something like infinity or oh, we only update the infinity, right? So we push it. What should we do here? I'm thinking that whether we should push all the elements in and check when they are popped, when they are unshifted, shifted, or we can check the distance before we push them into the queue. Since already this one is already in the queue, we pop it, we shift it. So actually, yeah, let's just do the check before we push them into the queue. All right. So the element, the the elements in the queue are to be updated. Okay, let's do it. It will be rooms. It must be infinity when we're going to update. Oh, no. It's not. If it is like, if this 2 here, and then we got a distance from 1. So, yeah. 0 is a special case, right? For the other case, we should stop. Wait. 0 is a special case, and if it is 0, we just push the possible elements in. Oh, I think we need to check both. Check it against the first one, or no. I'm a little confused. Wait a second. Yeah. We don't need to check we would check only if the next one is 0 or -1. If not, we push the elements in. But when we get the elements from the queue, we need to check if the distance is smaller than us. Okay, yeah. So this is the distance we're gonna be. So if distance rooms ij is not 0 and it's not -1, we won't push -1 in. We won't push -1 in. There's no need to check it. So if this one not 0 and it's smaller than, it's bigger than distance, well, if it's bigger than distance, then it cannot be 0. Oh, cool. So we can just do here, right? If it's bigger than distance, distance is 0, so it couldn't be 0. Okay. We only update it when it's valid. So rooms ij set a distance, which means this one could be updated. And then we push the next possible coordinates in. So if rooms next so the one before it above it, if I is bigger than 0, okay, we set the next distance. Should be distance +1. Here we took the trick. We only update the possible ones when it is the distance right there is bigger than us. So that we don't waste our time. Yeah. The one above this one, the current distance of it. It might be infinity, but infinity is just a number, so it will be bigger than, if it's bigger than distance. Q we push I minus 1. Oh no. J next distance. Well, we will continue doing this. If I plus 1 is smaller than rows, if j is bigger than 0, why we're adding the check here? Because like we put like we put this inf here, and there might be 1 point, which is next one, this point be the same in a queue, right? In a queue, and it is already updated. Then we cannot just directly assign the new distance. It might be already updated by some other route. Okay, we got this. Yeah, I think we're done. What do we need to return? We don't need to. Let's just try to review our code before we submit. Okay, this is the regular case. Okay, this is a walk method. When we walk on something, it is 0. We start walking. When we walk, we use a queue, which is a use BFS. We start from it because this set to 0 for the initial distance. Every time we get one from the head, we check the distance with the current one. If the distance is smaller than the current one, then we update it, and then we get the next distance and get the forward coordinates from around it, which is this one or this one, this one or this one. And if they have a bigger distance, like inf -1 will be always the smallest one, so we cannot update them. It will be filtered out in the if check here, and we push the next batch of coordinates in. Looks good. Let's try to run the code. What this? Huh? Uh-oh. We need to return. Huh? Really? We need to return? Really? No? Ooh. Okay, let's see what happens. We walk. We use a queue. Ready? You can slot j distance with a queue. 0, 0, 2, 0. So we should get we got 3, 0. Huh? There's no nodes above. Get the below it. Must be bigger, right? So we pushed it in. The queue is empty. Really? It's strange. Ah, God. I made it. I'm so stupid. There is a special case. It's if itself is 0, then the 0 must be step on 0. So there's a special case as a start. It should be distance 0. Yeah. Oh shit. I just yeah. I'm stupid. How should I say? Or we could just say no. This is right. Or we could say actually if it's 0, we can start. Yeah. We'll try submit. Cool. Or accepted. So the idea is BFS for this kind of thing. Time. Well, we loop through all the MN nodes, so n by n. And then we start 0 and check the nodes around them. For each node, it will be updated like, I don't know the worst case, but if you think that the zeros are averagely split, suppose k zeros averagely, it will take up mn divided by k areas, right? For 0, we'll take up this, and it will update. So first batch. First batch, it will go through all the MN nodes, but then the next one will just go to I think the M and K. The third one will also take M divided by K. So generally, I think there will be Mn plus K times Mn K, something like this. So still O Mn. This is a walk thing. So totally it should be still Mn, I think. Space, no extra space, it's constant. Cool. So that's all for this one. Hope it helps. BFS. Yeah. Okay. See you next time. Bye-bye.